The observable universe spans an area of about 90 billion light years. It can be assumed that the part of the universe we cannot observe is much larger. Space is so vast that the human mind simply cannot comprehend it, at least for now. However, according to some theories, it may turn out that space is much smaller than it seems to us. How is that possible? Welcome to the Hubble channel. Today we will try to guide you across the bridge, connecting the macro and micro worlds. According to current data, the part of the universe that cannot yet be observed may be about 20 trillion light years in diameter. Just imagine. Based on the data we have, we can assume that most of outer space must be empty, because the amount of matter in our part of the cosmos that has been studied is quite small. When we look into space, we see gigantic, vast expanses of icy emptiness. But what if the universe could fit inside a single atom? Does that sound absurd? Don't be quick to turn on your skepticism. This theory, which sounds more like philosophical science fiction, might not be so unbelievable after all. But first, remember what you know about matter. All matter consists of tiny particles, atoms. These tiny things are the very foundation upon which the universe, as we know it, is built. Atoms are so small that even with the most powerful optical devices, we can't actually see them. Here's an interesting fact. In reality, we can't even know for sure what an atom actually looks like. We can only make assumptions based on scientific theories. Even though we can't see atoms with our own eyes, it's considered a proven fact that atoms themselves are made up of even smaller subatomic particles, such as neutrons, protons, electrons, and quarks. Nowadays, it's well known that atoms are so numerous and tiny that the body of an average adult consists of approximately 7 octillion atoms. Let us remind you that this number can be represented as a 7 followed by 27 zeros. Just imagine that amount. But the atom in turn also has its own structure and a complex composition. It is precisely this that allows us to consider the incredible theory of the micro-universe. So what does an atom look like from the inside? From your school chemistry course, you probably remember that an atom consists of a nucleus, which is made up of protons and neutrons and electrons moving around it. This model, proposed by Ernest Rutherford in 1911, was called the planetary model of the atom. Indeed, the analogy is obvious, since the movement of electrons around the nucleus is very similar to the movement of planets around the sun. Moreover, this model has never been disproved and is even confirmed by modern research, with the caveat that the movement of electrons should be described by the laws of quantum mechanics, not classical mechanics. That is, the smallest particle, which is the basis of matter, has a structure similar to, no more and no less, the solar system. Could this be just a coincidence determined by the laws of physics? Or is there something more, something much more fantastic hidden in this similarity? Let's come back to this question later, but for now, try to answer this. How many electrons are there in our universe? It sounds absurd, doesn't it? Even the most powerful computer couldn't process such a number, let alone the human brain. But what if I told you that there's only one electron? This is exactly the hypothesis called the one-electron universe theory, proposed by the American physicist Richard Feynman, and it sounds like pure science fiction. According to it, there is only one electron in the world, which moves through space and time so quickly that it seems to us as if there are countless electrons. Just one particle gives shape to everything we consider the entire universe. How do you like that? Of course, this theory didn't gain many supporters, but the funny thing is that thanks to the principle of electron indistinguishability, the impossibility of experimentally telling one electron from another, it can't be disproven. That's quite a paradox. But let's get back to the structure of the atom and the incredible theories it gives rise to. Let's try to answer the question, what is the size of an object? Despite the everyday and familiar meaning of this word, in reality, the concept of size is quite mysterious and relative. For example, the world around us is tailored to our size because we built it. But when it comes to the creations of nature, things are far from simple. Mountains are huge for us, and planets are so gigantic that it's impossible to comprehend. And then there are ants, as well as all microforms of life, from just small to microscopic. But do ants consider themselves small? Do they realize that they live in a world of giants? Hardly. Their world is as familiar to them as our world is to us. Compared to cosmic objects, we are not even microscopic. We're talking about even smaller scales. That thought gives me goosebumps. And it's no wonder. It's not for nothing that the great master of horror and science fiction, Howard Phillips Lovecraft, promoted the idea of humanity's insignificance in the face of the endless cosmos in his works. And here we come to the main question of our video. But what if our universe could fit on the tip of a needle? What if the solar system is just an atom, one of countless others, that make up some other kind of matter? Building on this idea, it's logical to assume that the atoms and particles that make up our very existence could also contain entire worlds within them. So as one wise man said, infinity really is not the limit. It turns out that's the case. Our reality really could exist on the subatomic level of an entirely different reality. In the same way, entire worlds could exist on the subatomic level within our own reality, and so on to infinity, both towards smaller and larger scales. Sounds unbelievable, but exploring the unbelievable is our job. The most interesting thing is that by looking at the universe we know and observing the laws that operate within it, we can easily come to the same conclusion. Everything starts with the tiniest particles like atoms and ends with colossal celestial bodies and entire star clusters. Everything, from your lunch today to some newly discovered exoplanet, is made of the same building material. The dream of the scientific world is to find a theory of everything. The question of the relationship between the micro and macro worlds is a crucial building block in working on this theory. By reconciling quantum mechanics and classical physics, generations of young scientists may be able to understand the true nature of our universe, and even what lies beyond it. After all, even according to one of the most popular theories about the origin of our universe, it began as an infinitely dense and yet tiny singularity. Then, from this small point, it expanded to all known limits. This is called the Big Bang Theory, from something small to something much greater. Doesn't it seem to you as well that this quite relates to what we've talked about today regarding the micro and macrocosm? Yes, but there's also an important remark. A point is not the same as an atom. The singularity that gave rise to the Big Bang, despite its small size, contained everything necessary for the creation of the entire universe. And you still can't call that originating from a single atom. There is also the so-called string theory. It's an excellent candidate for a theory of everything. The main idea of this incredibly complex theory, which has many interpretations, is that an atom is not that spherical object whose shape and appearance we remember from school. It's more like strings or something very similar to them. The relationships between these vibrating strings include almost everything known to science. The laws of classical physics, including gravity as well as quantum mechanics. But string theory also has its weak points. While it explains a lot, it starts to stumble, for example, when it comes to dark matter, where string theory begins to falter. But there's no need for pessimism. Scientists have been working for a long time to incorporate the study of dark matter into string theory. At the end of 2018, Swedish scientists published a new version of string theory, according to which our universe exists on the edge of an ever-expanding bubble. This version rejects the 4 dimensions we are used to, 3 spatial and 1 temporal, and suggests that our entire universe is merely fluctuations on the surface of this bubble. What happens inside the bubble or at a distance from it remains a mystery. How do you like these prospects? We are just one small civilization, a dot in a tiny piece of reality located on the surface of a bubble, which itself in turn may be part of something much greater. Perhaps our entire world is just a proton or a quark, just a tiny particle of reality. Why don't we feel this in any way? Does the atom that makes up your sunglasses feel that it is just an atom, part of the plastic? But is it really that important to get a definite answer to this question? After all, we should only be grateful that our vast common home called the universe is full of such amazing mysteries. The universe is an amazing place, filled with inexplicable phenomena and epic events. The most astonishing of them are gamma ray bursts. They are accompanied by monstrous releases of energy caused by powerful explosions. Fortunately, such phenomena are observed in galaxies that are extremely far from Earth. If the situation were different, the solar system and humanity along with it would hardly have a chance of survival. So, what exactly are gamma ray bursts and what types are there? As a rule, gamma ray bursts are divided into short and long ones, lasting from a millisecond to an hour or more. This deadly, yet even from a distance impressive phenomenon, is a relatively narrow beam flying in opposite directions at nearly the speed of light. It appears at the moment of a supernova explosion and marks the magical moment of the birth of a neutron star or a black hole. This is not the only scenario. Sometimes gamma ray bursts also occur during the merger of neutron stars. But what the Swift Space Observatory recorded goes beyond classical explanations and is even a little frightening. Today we will talk about the giant gamma ray burst ring, consisting of 9 gamma ray bursts and being one of the largest known structures in the universe. Gamma ray bursts were first discussed as a phenomenon on July 2, 1967. The thing is, American spy satellites of the Vela system detected a strange burst, the source of which could not be atmospheric or cosmic phenomena, and certainly not nuclear tests. Such a discovery came as a complete surprise. That's why hundreds of probabilistic models were proposed to explain the origin of gamma ray bursts, and more than 5,000 scientific papers have been published on this topic. By the way, how can a gamma ray burst even be detected? Thanks to a method called spectroscopy. The electromagnetic spectrum covers electromagnetic waves with different frequencies. In this video, we're interested in the most energetic ones, which are related to ionizing radiation, within which gamma rays can be detected. After the detection of the first gamma ray burst, recorded as gamma ray burst 670702, many other similar discoveries have been made. These included short, long, nearby, distant, and other types of evidence of the consequences of monstrous explosions in deep space. At first, scientists were at a loss, wondering what could have caused such intense bursts. Another question, where could these bursts be coming from? The first theory suggested was that these are echoes of events happening not somewhere far away, but right here in our own galaxy. But when the study of gamma ray bursts reached a new level, it became clear that these phenomena are distributed throughout the entire universe and are usually much farther away than the boundaries of the Milky Way. Meanwhile, the list of gamma ray bursts continued to grow. But what was discovered in July 2015 by a group of Hungarian and American astronomers shocked the scientific community. The discovery was preceded by the following. At different times, data from several observatories around the world were systematized, and based on this information, conclusions were drawn about the discovery of a certain structure located implausibly far from us. So, what did the scientists discover? A giant ring of gamma ray bursts stretching over 5.6 billion light years is considered the largest object in the universe. ranking just after the Hercules Corona Borealis Great Wall. The distance of this mysterious structure from Earth is also impressive, over 9 billion light years. Visually, if observed from the surface of the planet, the ring formed by 9 gamma-ray bursts would be 70 times the diameter of the full moon in the sky. It is remarkable that all the point bursts are at the same distance from Earth. This raises the question, what is this gigantic structure and what is its origin? According to some assumptions, the Titanic sphere is a kind of projection of explosions that occurred simultaneously. More precisely, they detonated one after another within a relatively short time span of about 250 million years. Scientists admit that this phenomenon is extremely rare, and the chance that such a structure could have formed at all is 1 in 20,000. And yet, what is it? One of the theories suggests that we are dealing with a giant supercluster of galaxies surrounding a massive clump of dark matter. But the boldest hypotheses are the following. Some astronomers observing the object are mentally trying to enlarge the discovered structure even more, even though it's already quite large. The proponents of the mentioned theory claim that we are only observing the inner disk. The outer one, they say, reaches a diameter of 10 to 12 billion light years. If this is true, then it can confidently claim the title of the largest cosmic structure. But the cosmological theory states that such conglomerates are impossible due to the isotropy of the universe, which does not allow for random fluctuations. In fact, this also means the impossibility of the existence of colossal galactic walls discovered by astronomers in recent years. What conclusion can be drawn from this? Either the cosmological theory misinterprets some aspects of the universe, or the superstructure so precisely outlined by 9 gamma-ray bursts exists only in the imagination of astrophysicists. How dangerous can such bursts be? To get at least some idea of the scale of energy released by gamma-ray bursts, we need to compare them to something familiar, like the sun. If we assume that our star were to explode one day like a thermonuclear bomb, the energy released would be equivalent to a single burst, and not even the strongest one. An explosion like that at a distance of 10 light years from Earth would be deadly for us. Just imagine, in a matter of seconds, such a terrifying amount of energy would be released that it could be compared to an atomic bomb exploding on every hectare of the sky. And we assure you, Earth's atmosphere won't help us. All living things on the planet would be wiped out in an instant. Even if the explosion happens at a distance 100 times greater than stated, the consequences for Earth and its inhabitants would still be very dire. Accordingly, each gamma-ray burst is capable of wiping out all life within a radius of thousands of light years. Fortunately, this phenomenon is relatively rare. However, considering the extinction of the dinosaurs, which may have occurred as a result of one of these events, significant damage to Earth's biosphere is inflicted at least once every few hundred million years. By the way, some gamma-ray bursts can be seen with the naked eye, even though they are billions of light years away from the solar system. But let's get back to the unidentified circular structure discovered in the depths of space. Scientists are wondering what could have created such a titanic formation. At different times, the candidates responsible for gamma bursts have included black holes, comets, giant stars, and even cosmic brains. But now, astronomers seem to have made up their minds and narrowed down the suspects to neutron stars and supernovae. At the moment, unfortunately, it is impossible to determine with certainty whether such a massive conglomerate exists in the observable region. So astronomers' assumptions are more like reading tea leaves. But the world does not lose hope. Perhaps soon, new, more advanced observatories will appear that will be able to look even deeper into the cosmic darkness to discover and bring to light all the skeletons in this universal closet. Man is the highest stage of evolution, the most intellectually advanced species living on Earth. Knowledge is a fundamental need of Homo sapiens. Thanks to insatiable curiosity, man has made life more comfortable, subdued other species, and confidently set his sights on the vastness of space. And although the car is no longer the ultimate dream, and the computer has moved from the science fiction section of the library into every home, there are still areas where we are absolute children. And one of these areas is the teleportation of objects over a distance. This is one of the favorite topics of science fiction writers who, as we know, are always ahead of their time and provide inspiration to scientists and inventors. Alfred Bester, Tal Klein, and Stephen King have written about teleportation, but while teleportation is described in great detail in works of fiction, in the real world things are far less optimistic. Research in this field has been going on for a long time, but so far, there have been very few significant results. Can the plots of science fiction novels come to life? Or will teleportation remain only on their pages? What could this convenient but extremely risky way of travel mean for humanity? A progressive breakthrough or a curse? Let's try to figure it out. Teleportation. The term itself comes from Latin and consists of the words to carry and far away. To put it simply, the process involves instantly moving an object to any point in the universe. The term was introduced in 1931 by the American writer and researcher Charles Fort. It's worth noting that the concept includes several types of teleportation, including the most popular one in the 21st century, quantum teleportation. Quantum teleportation started being discussed seriously in 1993 after the publication of an article that described this phenomenon. Naturally, there was no talk of instantly transporting a person from one place to another. Even now, we are incredibly far from that. The experiments were conducted exclusively with elementary particles, and despite how magical it may seem, it has nothing to do with magic. To understand the essence of the process, you need to accept as an axiom the fact that all objects are a set of informational algorithms. Humans are no exception. Therefore, teleportation primarily means the transfer of information from one place to another. In the case of photons, it looks something like this. The sender has a particle in a certain quantum state, which he wants to transmit to the recipient using an exact description. At this stage, the emphasis is on accuracy rather than speed. But if there is a theoretical basis, does that mean that teleportation might soon become a reality for us? Charles Bennett was the first to mathematically prove that this is possible. However, at that time, no one even thought about applying these calculations in practice. Other unexplained phenomena were also indirectly discovered, such as black holes, whose existence has not yet been experimentally proven to this day. What happened later was strikingly different from the scenarios in Hollywood movies, where another Arnold Schwarzenegger would dashingly teleport to Mars. Experiments continue today, but so far, only information about an object's quantum state, not the material object itself, has been transferred. And this is already a major scientific achievement, because theoretically, an informational manual is enough to successfully reconstruct the original object in a new location. By the way, the process of teleportation is familiar to us in everyday life because it can be compared to a fax. The sender doesn't send the actual document, but electronic information about it. The recipient receives an exact copy of the required paper, and yet the difference between a fax and teleportation is significant. In the second case, the original object is completely destroyed and is reborn in a completely different location. What is the quantum world, and is it different from the familiar one? Yes, and very much so. A vivid example is particles that are in superposition. Judge for yourself. In reality, a person cannot be both alive and dead at the same time. Reality forces an object to choose a single state. But quantum reality is not like that. Particles in it, like Schrodinger's cat, can simultaneously be in both states as long as no one is observing them. In other words, a kind of superposition of one state over the other occurs. This is exactly what Schrodinger's paradox is about. The cat is sitting in a closed box where, theoretically, at any moment, a device could be triggered that releases poisonous gas into the box. And as long as the box remains closed, it's impossible to predict the state of the kitty. The gas trap can be triggered by chance, and the probability of this outcome is exactly 50%. Thus, for the observer, the cat in the box is both alive and dead at the same time. It's hard to understand this, which is not surprising. For several decades, the greatest minds in the world have not been able to fully comprehend this mind-boggling information. But that's exactly how quantum physics works, and the best minds of humanity will have to keep figuring it out for a long time. How can quantum teleportation work? For it to work properly, a condition must be met: entanglement of two elementary particles. This inexplicable connection allows particles to read each other's state even over vast distances. When discussing this fascinating question, Einstein's famous phrase is often mentioned: God does not play dice. What do dice have to do with this? They are directly related to the subject of the scientific debate because using analogies makes it easier to understand the essence of entanglement. Imagine you have two dice that always add up to 6. If you roll one of them and it shows a 2, then the player will know exactly what the value of the second dice is, even without seeing it. A similar situation occurs with entangled quantum particles. Why does the universe make everything so complicated? Well, no one ever promised us the ease of existence. This phenomenon is difficult to comprehend, but that doesn't mean the mentioned principle can't be used in practice. Experiments in this direction began decades ago. Their initiator was Professor Anton Zeilinger from the University of Vienna. The experiments started in the Canary Islands. In a laboratory on the island of La Palma, a pair of photons was created. One of them was later sent to neighboring Tenerife, which is 150 kilometers away. The particle literally traveled on top of a laser beam. Then, a third particle, a candidate for teleportation, joined the photons in superposition. After that, photon C interacts with particle A, which is on the island of La Palma. And that's it. The scientists learned the state of the entangled photon B from Tenerife. And then it's just a matter of technique. B turns into an exact copy of C, meaning teleportation has occurred. If you leave out the scientific details, it turns out that the information about the original ended up in another location, where, with the right skills, you can recreate an identical copy. But how can all this help with the main question? The possibility of teleporting a human. Will we be able to travel without using spaceships and other devices? Theoretically, yes, but in practice, it's not that simple. What is necessary to carry out the process? First, teleportation booths located in different places, as well as an entangled pair, each in a separate booth. In the third booth, there must be an object to be transported or, if you prefer, cloned. The computer compares its state with the entangled particles and sends the information to the teleportation point, where a copy of the object is created. Of course, things only go smoothly on paper. Think about it. If the computer scans the information incorrectly, instead of you, a fruit fly, a centipede, or just a plain potato could appear in the teleportation booth somewhere on Venus. And there's simply no chance of returning to your original state because the source material has been destroyed. You might say, is a computer even capable of making a mistake? Who knows? After all, our bodies contain about 7 octillion atoms, more than there are stars in the observable universe. If you add to that number the neural connections, linking them in the correct order, it becomes clear that at the current stage of technological development, this is pure fantasy. But if, in the foreseeable future, supercomputers capable of processing enormous amounts of information appear, it's possible that humanity will make another progressive leap forward. Right now, we are actively observing exoplanets with telescopes, painfully wondering whether there is life on these celestial bodies. And with the development of quantum teleportation, the problem will automatically disappear. People will not only be able to study planets in person, but even organize tourist trips to them. Can teleportation bring humanity closer to a first-level civilization? Yes, but there is one unpleasant nuance. Even if everything works out as expected, will the teleported person retain the traits of a unique personality? By the way, a similar problem arises for scientists trying to develop a way to upload the human brain into a supercomputer or another electronic medium. Perhaps teleportation will only be able to transport inanimate objects, not living beings. After all, no one knows yet what exactly makes each person a unique individual. Psychologists of the future will have to answer these questions, since the ethical side of teleportation is much harder to resolve than the technical one. And while physicists are thinking about increasing the distance between teleportation booths, not even considering interstellar journeys or the problems of preserving identity, we know this will definitely happen. Subscribe to the channel, like the video, and suggest new ideas for traveling at faster than light speeds. Let's bring the future closer together.